So hello, welcome to another day of physical science. But unlike other days, I'm not going to teach any new material today. General ideas, today is going to be review for the exam, which is Wednesday. Wednesday being March 3rd. What I'm going to do today is I'm going to go through last semester's exam. As I go through last semester's exam, I will give hints and tips and secrets about how I grade in general and what it's going to be like. I am doing this with the PDF of the exam open, which is not the same as the full way you guys see it online. That's more just to make my life easier of how it pops up. Keep in mind the exam is on Banco Hall. It's going to open up in the same kind of format-ish as your homework and labs. Um, what's going to happen is when you open it up, it'll have a list of 5 problems on each page. You will do the work on a piece of paper, write it all out, take a picture of your work, and upload in sections of 5. So the first 5 gets one photo, the next 5 gets the next photo, and so on. The exam is going to open at exactly noon and is going to close at 1:05. What I'm giving you is 50 minutes to do the exam and 15 to upload it. There is theoretically nothing stopping you from spending all 65 minutes doing the exam, other than if it isn't uploaded at 1:05, it's a 0. So make sure you give yourself enough time to upload the exam. Don't work to the last minute because you need to upload it. How long it's going to take you to take the pictures and upload, that depends. That's on you. I don't know. That is part of the reason I have last semester's exam in the same format, so you can try and see how long it would take you. So if you want to try doing and to seeing how long it would take, go for it in last semester's exam. I'm not going to grade it or anything, but you can just upload anything you want, really, and I'm never going to look at it. Although now that I say that, I'm almost tempted to look at it and see what random shit I get. But you can use that as a way to see how long it would take. But yeah, 15 minutes for the exam, an extra 15 minutes to upload. Post the time how you want, but how you deal with that time is up to you. Once again, you must work by yourself. You can go open notes, but don't spend too much time flipping through your notes because that's a waste of time. Any questions about the exam format before I start going through review?
Do you want the pictures as PDF file, I'm guessing?
I don't care. PDF, photo, as long as it's visible. A lot of the people, I just get them as a JPEG or a what's it, HEIC is like the weird one that Apple sometimes uses. They all work as long as it's a version I can see, but it doesn't need to be PDF. I'm fine with JPEG and TIFF and anything photo based.
Okay,
If my
thank you.
computer can open it, I'm happy. Any other questions? Okay, so the exam setup. The first page of the exam, which for you guys will once again not look quite like this. You know what? I should just real quick here. I'm going to put this on a different screen for a second. As I get started, I'm going to open it up what the exam is going to look like, just so we can make sure we're on the same page. The first page of the exam will be from chapter 1. Chapter 1 is was all unit conversions and some other just base science things like what is a law, what is a theory, and things like that. Here. Once again, to show you what it looked like on the actual exam, this is what the actual exam looked like. So it's these 5 questions and a spot to upload. So these 5 questions are going to be the same as these 5 questions. I just added a picture in the end for fun. So So I'm going to do it on paper just like I would, and would I take a picture and upload. I'll say how I grade as I do it. So it'll probably have at least one unit conversion raised to a power, at least one metric unit conversion, and the other bits would be based off the prerequisite science stuff I covered. Last semester, I started with what do we call a scientific generalization based on empirical observations of physical behavior that explains a simple scientific concept that is universally believed to be true. That is a very fucking wordy question. But general idea, the big thing to take away here is I say universally believed to be true. This is a scientific law. Now, on ones that'll just answer a question, it's normally all or nothing. You either got this 5 points or you didn't. Each question will be worth 5 points. I don't know if I said that before. But that's all it was. The next one. Which of the following is not an SI unit and will need a conversion before using? Meters, grams, seconds, amps. SI units, we always work in very set units. Meters, kilograms, seconds, and some other things like amps. The answer here was grams. Because grams need to be converted into kilograms. And if grams isn't converted into kilograms, you're going to get the wrong answer. Once again, this was all or nothing. Now, before I get into unit conversions, as I said, there's normally going to be 2 questions that are like this. If I don't do law and grams again, other things to expect would be scientific method, know the steps. Scientific notation, like here's a big number, convert it into scientific notation, or here's one number of scientific notation, convert it to a big number. Know the branches of science was a quick thing I covered, just like what makes up physical science. It's like one slide in the notes. I could go further with laws and theories, although I did laws and theories last semester, and since I'm giving you the answers to last semester's exam, it's probably not likely I did the same thing again. Same logic with fundamental units. Okay. Oh, other quick side note, the solutions to last semester's exam is on Vanco Hall in typed version. That didn't come back. So the next question is my first unit conversion. And it says, the original Super Mario Brothers for the Nintendo was 40 kilobytes. How many bytes is that? When doing any unit conversion, start with what you know, 40 kilobytes. Oh, just KB. I don't know why I put an S there. And what you're going to do is you're going to multiply by a ratio that cancels out the unit you want to get rid of and gets the unit you want to get back. I want to turn kilobytes into bytes. And so that's why I'm going to set it up that way. Sorry, I just remembered I have something here that could help me. As I make a mess. So that is what I'm going to want to convert. And so what I'll say is, looking at that, using that logic, exam two. I've just remembered I have the grading rubrics, and since I'm going to say exactly how I gave up points, I might as well show you exactly how I gave up points. But I forgot to pull this out ahead because I'm bad at my job. Okay, fuck it. This is a mess. I'll just do it by memory. So what I need is the conversion between kilobytes and bytes. Now this is metric. When doing metric, I won't necessarily tell you how many kilobytes are in a byte, but I'll tell you how many kilo or how many base is in a kilo. If I look at this right here, I have K, 1000, 10 to the third. What that means is there was 1,000 kilobytes in a byte. It also means that there was 1,000 meters in a kilometer, that there's 1,000 seconds in a kilosecond, and so on. And what I can do is I can multiply across, canceling out my kilobytes and getting my answer. Now, usual grading thing is 3 points for the process, 2 for the answer. The 2 for the answer, 1 is for the number, 1 is for the unit. So if you forget units or put the wrong units, you'll lose 1 point. Just for setting up a ratio, that is 3 points. So setting this up is 3, 1, 1. If you don't know how to do a problem, but you know the equation, just write the equation. If you get the equation right, that's 3 points. Any questions though? The problem then says, we can define the unit of a Mario is equal to 40 kilobytes. Super Mario Odyssey is 5.7 times 10 to the 6 kilobytes. How many Marios big is that game? And so we're going to do a unit conversion where we're going to cancel out kilobytes to get Marios. Well, one Mario is 40 kilobytes. It's kind of crazy to think how small that is. Like 40 kilobytes is like lower than like a photo normally. And I'm going to put kilobytes on the bottom because that's what I want to cancel out. I'm going to put Marios on the top because that's what I want. Of note, I normally do units you can't just Google because I want to make you do it and can't just Google it. So expect some weird fucking units. This will allow my kilobytes to cancel, and I multiply across. 5.7 times 10 to the 6th times 1 divided by 40. So basically, I'm just dividing by 40. Once again, it was 3 points for the process. Yeah, 3 points for the process, 2 for the answer. One of those was reserved for the unit. Any questions there? Apparently I didn't save exam 1. Okay. The last one on this page was unit conversions raised to a power. These will almost definitely show up. And it says Harvard Bridge, the one which was measured in smoots, has an area of 13900 meters squared. Convert this to smoot squared. And so same logic. I want to cancel out the unit I want to get rid of to get a new unit. And I'll just say one smoot is 1.702 meters. However, meters is squared. Because my meters is squared, I need to square my conversion factor. And this means my smoots will get squared, my meters will get squared, but so will this 1.702. And so it's 1.702 isn't my conversion factor. It's going to be whatever 1.702 squared is, which for the record is 2.8968. This will allow my meter squareds to cancel. And I'll multiply through. I gave 1 point for just canceling out meters to get smoots, 2 points for remembering to square this shit, and then 2 for the answer. Once again, your exam will not be exactly the same, but it will have a unit conversion in metric, it will have a non-metric unit conversion, and will have a unit conversion raised to a power. The other two, a little more open-ended. Any questions there?
How do you get for question 5? How do you get 2.8968 meters? Like where do you find that?
That's 1.702 squared.
Oh, gotcha.
Any other questions?
Do you want us to write out the whole question, or is it fine if we just do like how you did it?
This would be fine. There's no need to write the question. I know the questions. I would do just like what I have here would be perfect. I recommend showing some work because I can give partial credit if there's work. If you just write an answer and no work and it's wrong, you get nothing. Like if you had written like full 598, that's all you wrote, I'd be like nothing. If you write this and then full 598, I'd be like, oh, you made a math error. That sucks. I would take away 1 point and just be like, sorry, I feel bad doing it. So it's better to show your work, but this is all you need. Any other questions? Okay. The second page will be from chapter 2. Chapter 2 was all about, I guess, things moving. It's called motion. velocity, acceleration, free fall, terminal velocity. I'm probably going to work speed and or velocity in somewhere. Speed, keep in mind, is distance over time. Velocity instead is displacement over time. And problem 6 said a human sneeze can travel 2 meters in 0.0462 seconds. What's the average velocity? Well, if I say average velocity, that's v average, which is displacement over time. Right there, that's 3 points out of 5, just for that. And I'll say, okay, the distance was 2 meters, and the time was 0.0462 seconds. I have before asked for time. If I ask for time, you have to rearrange the problem. I have before done things like on the homework, there was one about like the track and the answer was 0 because displacement was 0. I've been an ass and been tricky like that before. Just keep in mind velocity is displacement over time.
How would you rearrange the equation if it were like a different, if you were asking it a different way?
Let me do number 7 where I bait is very similar and is going to be more like that. Well,
Okay.
no, actually it isn't because I'm going to start with a different equation. So that's a lie. If I ask you to solve for time, I would multiply both sides by t. And then I would divide both sides by v.
Thank you.
No problem. Number 7. During takeoff, a Boeing 747 accelerates at 2.6 meters per second squared to go from rest to a speed of 82.3 meters per second. How long does this take? If I'm talking about velocity as a function of time, whenever I talk about velocity as a function of time, that was this guy right here. That velocity as a function of time is v final equals v initial plus acceleration times time. 3 points right there. Now it said it started at rest. Starting at rest means v initial is 0. And so v final is acceleration times time. If I want to get time, I'll simply divide both sides by a and say it's v final over a. Or 82.3 meters per second over 2.6 meters per second squared. Once again, 3 points, 2 points.
If we make like the T or like if we make those capital, will that be an issue or?
No, I will be nice and not be an ass about that.
Thank you.
It bothers me deep down inside, and I'll go, meh, but I'll give full credit.
All right. Thank you.
No problem. I just grabbed a different pen by mistake. Okay, next one. There will be some in here that aren't necessarily mathematical. The non-mathematical ones are often things like just asking a question about terminal velocity, though I seldom use that. Projectile motion is sometimes some. Keep in mind that complementary angles have the same range. I've done a few things like that. It's kind of like the multiple choice questions on the homework. But this one says a ball is thrown directly upwards. What is the acceleration and velocity at its highest point? Anytime something is in the air, the acceleration is negative g. I would also accept negative 9.81 meters per second squared. At the highest point, your velocity is 0. How I graded this was 2 points for this, 3 points for that, where if you forgot the negative sign, it was only 2 points. I took off 1 point if you forgot the negative sign. Oh, G. I'd accept negative G also. Negative G was also 3 points. But G or 9.81 was 2 points. Negative G or negative 9.81 was 3 points. The one constant I can tell you is there will be a question about free fall on here. Normally 2 of them. When doing free fall, your equations are going to be these down here. You cannot use the average velocity equations for free fall, as most of you did on the lab, because well, it'll give you the average, but won't give you the instantaneous. That there was an acceleration, so it changes. And so there will be free fall on here. It's going to happen. Last time what I asked is, in the movie 300, because that's from the past right there, Leonidas kicks a messenger into a pit, and the messenger falls for 2.49 seconds. How deep is the pit? If you want to find the distance someone falls, distance is 1/2 gt squared. 3 points right there. And so the distance they fall will be 1/2 g times t squared. Things that can change up is sometimes I give d and ask for t. If I give d and ask for t, just rearrange and solve for t instead. We've done problems like that. In class, we did it with a penny falling off the Empire State Building. So you can look at that if you want an example. I do sometimes work problems together. So problem 10, it says using question 8, how fast is the messenger falling when they hit the bottom? In free fall, your velocity is negative gt. So it's negative g times t, with the negative sign representing downwards. One thing with this, if in problem 9 I gave you d and asked for t, and I'll talk about that later with another one. Sorry, let's not do hypotheticals. I'll explain what I mean a little bit. I think. Maybe? Okay. I got one. I can show that later on. Any questions there?
Yeah, I'm having a little trouble with like number 9. How you get 30.4? Like how would you put that in the calculation, like the 9.81? Is it like 9.81 times 2.49 squared? And is that like how you get it?
Just like that. 1/2 times 9.81 times 2.49 squared.
Yeah, thank you.
How many integers are you gonna want us to go in like the decimals?
I do not grade that in physical science. I say normally if you have 3 non-zero digits, that's fine. You can see I rounded everything to 3. That's fine.
All right.
Any other questions?
Yeah, for number 7, for the distance, like how you getting 31.7 like in the
That's not
calculator?
distance,
Like,
that's the time.
That's a time. Oh,
I did velocity divided by acceleration. So 82.3 divided by 2.6.
okay. Thank you.
No problem. The third page will be from chapter 3. Chapter 3 was all about forces and then buoyancy, torque, gravity, momentum, angular momentum. It started with forces, but then spread out like crazy. There was a lot of things I can do here, but the one thing I would definitely say to expect is F equals ma. Starting with the first one, it says Krog's Strongjaw from Critical Role has a mass of 235 kilograms. What is his weight? Now the equation for weight is not written on this screen, but weight is mg. Weight is mass times gravity. 3 points. And so his weight would just be his mass times g. "12 says that's us if you're on Earth, but critical role does not take place on Earth. It takes place on the planet Exandria, which has a radius that's given and a mass, which is also given. What's the force of gravity on that planet? If we're not on Earth, the force of gravity goes by this equation. And the force of gravity will be following that. That is gravity for anything not on Earth, or gravity between things that aren't Earth. Now, you do need to know what capital G is. And if I go back to the actual exam, before the questions start, there is a one with an I on it. And I will always give any constants you might need. This only has 2 constants right now, but as the semester goes, this will get more and more and more constants. And that includes G. And so the force due to gravity will be G times M1. It'll be the mass of the planet times M2, which would be the mass of Grog, over the radius of the planet. I love how the radius of the planet is a known quantity, which is squared. Once again, 3 points for the equation, 2 for the answer. Problem 13. Grog can apply a force of that. If he applies the force to a that x, what's the acceleration? F equals ma is going to show up. Expect it. It'll be there. In this one, I say, what is the acceleration? That means I need to solve for a. What I would do is I would divide both sides by m and say acceleration is F over m. It is 3470 newtons over 3.18 kilograms. Once again, 3 points for the equations, 2 for the answer. "14. In the problem above, how much force does the axe apply to Grog? That's Newton's third law. For every action is an equal and opposite reaction. If he applies 3,470 newtons to the axe applies 3,470 newtons to him. This was all or nothing.
Can you say that one more time? You said that really fast.
Sorry, Newton's third law. For every action is an equal and opposite reaction. Whatever force Grog applies to an axe, that'll be the same as the force the axe applies to Grog. And so if Grog applies 3,470 newtons, the axe applies 3,470 newtons back. That's the logic. For every action is an equal and opposite reaction. And number 15 was, let's say axe does this on frictionless ice. The axe leaves his hand at 205 meters per second. What's his velocity after the throw? This is somebody throwing something because they're throwing something moving backwards. That's recoil. We've done a bunch of problems about recoil. Luigi throwing a shell. Captain America throwing a shield. I could solve for recoil by saying conservation of momentum, where momentum is mv, or I could just jump straight to the recoil equation I gave in class. And in class, I said that the velocity of a cannon is the mass of the bullet, velocity of the bullet over the mass of the cannon times a negative sign. We don't have a cannon and a bullet. We got a Goliath throwing an axe. And so I'll say the thing doing the launching, that's C. Grog is doing the launching. So my C's become Grogs. And the thing he's launching is an axe. So I would say that's the thing being launched. And say the velocity of Grog is negative the mass of the axe times the velocity of the axe over the mass of Grog. Am I still on the page? I am. Now, F equals ma is definitely going to show up. Conservation of momentum and recoil is definitely going to show up. Past that, I can really mess around with it. I sometimes do weight, I sometimes don't. I sometimes do angular momentum. Take a look in the homework about the lady from Kill Bill swinging her weapon, or in the notes, it is a comet going around Earth. I've asked questions about buoyancy, but when I ask questions about buoyancy, it's normally just like, what affects buoyancy? And it's like density. I have also done questions about torque before, where torque equals RF. So, know those topics. Study the homework, really, is what I'm going to say. If you study the homework, you get the right idea. But I might change it up to some of those.
Dr. Oz, what you said? Kill Bill question, the comment. Like, what homework is that in? Do you know?
This is chapter 3.
Oh yeah, chapter 3. I mind. Okay.
I think it's a Kill Bill. I changed it because it was originally a Kratos question, but I put a different Kratos question on. So I'm pretty sure it's what's her name? It's been so long since I've seen Kill Bill. Go. She has a weapon that's a metal sphere on the end of a chain that she's spinning. I asked a question about that. It's actually a bright action figure over there. Any other questions on this? The fourth page will be all energy. This will consist of the physics energy, but also some like the renewable energies at the end. Normally it's mostly the physics energy, and then the whole types of energy and renewable energies is just a little bit added to the end. So no work, no kinetic energy, no potential energy, no conservation of energy, power, energy types, and energy sources. Now, for the record, this homework isn't due until after the exam. I highly recommend start it sooner than later. Try to do the assignment before the exam, because of the fact that doing the homework will help you prepare. I do ask similar things on homework as I do exams. So try to do the homework tonight or tomorrow night for your own sanity. How I started last time was I said Iron Man's repulsor blast from his gauntlets can apply a force of about 2,220 newtons. If he applies this force to an object for a distance of 2.16 meters, how much work is done? Work is force times displacement. That's the equation. It's actually force times displacement, cosine of the angle in between, but I'm not going to give you angles on the exam. And so it'll be the force he applies times the distance he applies it. Once again, 3 and 2 points respectively. "17 says, after applying the work found in number 16, what is the increase in kinetic energy? Well, you see, work is change in kinetic energy. And so the change in kinetic energy is 4,795 joules. It's just the same as the answer above, because that's what work is. Work is increase in change in kinetic energy. Now, this brings me to a side tangent. The answer to 17 is the same as the answer to 16. But let's say you messed up number 16 and you got the wrong answer, or you just have no idea how to do it. But you know that work is changed in kinetic energy. And so you know the answer to 17 is whatever the answer to 16 was. You can still get full credit for 17. If the answer to a problem relies on the answer to a previous problem, I would do through your work. Let's say you got like 500 for number 16, and you went and did it, and I don't know how, but somehow you got 500 joules. I would give full credit for 17 if you wrote 500 joules. Yes, that's not the correct answer, but it's only the wrong answer because you messed up the last one. I'm not going to hit you twice. Likewise, on that free fall question, let's go back to free fall for a second. If I ask you to solve for time instead of distance, and then I ask for the velocity, if you messed up getting the time, there's no way you can get that velocity correct. But what I would do is whatever number you got for your time, I will plug that in and check the answer. And if your answer is correct if your answer is only wrong because of a mistake you made earlier, that I already removed points for, I will still give full credit. You understand what I mean?
Yeah.
Okay. 18 says the force from number 16 is applied for only 0.821 seconds. How much power is exerted? Power is work over time. And so we'll just say the work, 4,795 joules over the time. And divide. Likewise, in the example I was giving over here, if you put 500 for that first one, draw. And you said here you did 500 over 0.821 and got whatever that answer is. I don't know what that answer is off the top of my head. I have to do the math. You'd get full credit because you put 500 up there. But the actual answer is 5,840. Power will probably show up. Work would definitely show up. Energy in some form will show up. Let's do number 19. When exploring Seattle in The Last of Us Part 2, you find yourself as Ellie sliding down a muddy hill. If over the course of the slide she drops 6.23 meters, what is Ellie's velocity at the bottom? Assume it is frictionless. Anytime you have something changing height and therefore changing velocity, what we can do is we can use conservation of energy. We can say the energy at the top of the hill equals the energy at the bottom of the hill, where the energy at either place is going to be kinetic energy plus potential energy. Now at the top, she's at the top and only has potential energy. At the bottom, they're at the bottom and only have kinetic energy. And so I can say mgh equals 1/2 mv squared. My m's cancel out. I can multiply both sides by 2 and square root. This one's a little more complicated for how I give credit. I think I gave 1 point for energy top equals energy at bottom, 1 point for 1 half mv squared, 1 point for mgh, and then 2 for the answer, I think is what I did. If you want other problems like this, take a look at the homework. There was something about people chasing cheese down a hill. It's a real thing. It's an old test problem. Or in class, I did the ski jump. Same idea. The last problem is almost always something from the last day we covered new material. I'll ask things about the types of energy, as in mechanical. Let's see if I can do these all by memory. I sometimes miss some. Mechanical, electrical, electroluminescent, chemical, thermal, nuclear. Did I say chemical yet? I did. Yep, that's all of them. There's 6. So I might ask about those. I also sometimes talk about renewable energy. And so last time I asked for 5 renewable energies, I gave 1 point for each one, and that's hydropower, wind power, solar. I just spelled solar wrong. Geothermal, tidal, and then the biofuel biomass. Although I don't really like biomass as a renewable, but that's a whole other story. But as I said, I might instead ask for types of energies. If I ask for types of energies, I'm looking at mechanical, thermal, chemical, electroluminescent. I gotta write them down because if I don't write them down, I forget what I'm saying. Like which mechanical, thermal, electroluminescent, electrical, chemical, nuclear. There's a lot of spelling mistakes in that. I don't grade spelling. I can't spell for shit. That's the types of stuff you can expect though. Questions? Okay. I got 7 minutes left. That's the general idea of the exam. Once again, it's not going to look like this just because that's what it would look like if we were in person. It'll look like this. But those were the same questions where you just flip through each page as its own thing. And I added photos. Sometimes I add GIFs when I feel fancy. I don't think I added any GIFs last time. And you just upload your work. So with my last remaining time, is there anything else I can either show you as a problem or try to help or anything I can do to be helpful?
Now, just so I'm double check, I don't get back until Wednesday from classes because I'm commuter. I don't get home till about 1-ish, 1:30-ish.
Okay.
So were you able to like open the exam later and then let me hand it in later?
Let's talk individually after I'm done recording because that's a special case.
Okay.
So let's talk and work something out.
Alrighty.
Just stay on when everyone else leaves. Any other questions?
No, that's it. But yeah, I get back tomorrow like around 12. That's it. I have a similar situation to Dom. And Dominic with I have a lab like right before, so I don't know if I'm gonna make it back right at noon.
Okay. Everyone who has like a personal time thing, I'm gonna put this. So everyone has a personal time thing. I think I will probably stop recording for the video for the people online because they don't need to work out everyone's personal details. But for those people, just stay for a second. We'll work them all through real fast. Other than that, any other questions, feel free to email me. I'm a little busy tomorrow, but I do still have my office hours and I can help there. And yeah, have a good day and we'll have an exam Wednesday. Oh, during the exam, I will be in Vanco Hall. So if there's any questions, you can log in and I will answer questions. I hope I will probably have it graded. I hope to grade it Wednesday night, but worst case, I'll grade it Thursday. I'll email you when grades are up. 5 o'clock Wednesday night, the solutions will post. The solutions will look a lot like this one, where it'd be typed up copies. Thing is, the numbers are randomized. So your numbers might not be identical. Your numbers might not be identical because the numbers are randomized, but the process will be the same. And you should be able to figure out what the exact answer should be from, plugging the numbers in the calculator yourself. But other than that, I will stop there. Have a good day.